organizations of parallel platform. Actually, in this topic, there are different number of subtopics are there. Okay, first topic is architecture of your idle parallel computer. Second one subtopic is interconnections network. Third one is your network topology. Then cache coherence. Okay, so these are the number of subtopics under this heading, that is physical organizations of a parallel platform. So we'll start with the first point, that is nothing but architectures of an idle parallel computer. For that purpose, we will consider one system, that is architecture parallel random access machine. Okay, so first topic under the parallel organization is architecture of an idle parallel computer. So what happened? The natural extension of a random access machine serial architecture is nothing but the parallel random access machine. In short, we can call it as a PRAM. So PRAM consists of P processor and a global memory of unbounded size that is uniformly accessible to all processor. So we can say that all processors access the same address space. So processors share a common clock but may execute a different instruction in each cycle. So what happened? This model, that's why this model is referred as a PRAM model, because what happened? A PRAM can execute the or allow for the concurrent access to a various memory location. So depending on how a simultaneous memory access are handled, according to that, there are four different classes are considered for the PRAM. So basically what happen in PRAM, processor share a common clock but may execute a different instruction in each cycle. That is the main concept regarding your PRAM. So according to that, okay, how we can concurrently access the different memory location. For that purpose, we can consider the four subclasses. So first class is exclusive read and exclusive write operation. So what happened in this particular class, access to memory location is exclusive. So that's why there is no concurrent read and there is no concurrent write operations are allowed. So among these four subclasses, if you are considering this class is a weakest class of your PRAM model, because here there is a separate exclusive read and the exclusive write operation is there. Okay, that's why it is considered because there is no concurrency. Okay, so it is considered as a weakest PRAM model. Okay, just wait 1 minute. Then another class is considered as a concurrent read and the exclusive write. Okay, so what happened in this class, we can have the multiple read access to a memory locations are allowed. Okay, but however multiple write access to memory locations are considered as a serialized. Okay, see, exclusive means we can consider a serial and concurrent is we are considering the parallel one. Okay, so here we can have the multiple read access to your memory location. Here only a write multiple write access to a memory locations are considered as a serialized. Now third class, exclusive read and concurrent write. So what happened? Multiple write access are allowed to a memory location, while multiple read access are considered as a serialized. Last class, concurrent read and the concurrent write operation. It means that there is a this class is going to allow the multiple read and write access to a common memory location. Okay, now see here in first class what happened, exclusive read and the exclusive write. Okay, so there is no concurrency. In second class, multiple concurrent read access to the memory location, because due to concurrent read. In third class, concurrent write is there, so multiple write access to a memory location is allowed. And in fourth case, what happen, multiple read and the write access to a common memory location is going to be allowed. So what happen among these four subclasses, a last class is considered as a strongest model or most powerful model of your PRAM. Okay, where first model, because there is a serially read and the serially write operations is there, so it is considered as a weakest model. So what happened if you are considering what does a concurrent write mean? Okay, because if you are considering allowing the concurrent read access, it does not create any semantic differences in the program. But if you are considering the concurrent write access to a memory location require the arbitration. So there are several protocols are going to be used to resolve such kind of concurrency rights. So there are, here we are considering the these protocols basically useful to resolve the concurrent right. One is a common. Okay. So what happened in that protocol, the concurrent right is allowed only if all the values are identical. Of all the values means that the processors are attempting to write are identical. So whatever the processor is going to use the write operation, and if the all the values are going to be identical, then the common protocol will be considered. Then arbitrary. So what happen, in which an arbitrary processor is allowed to proceed with the right operation and the rest one is get fail. So write the data from an randomly selected processor. Okay, so you arbitrary. Okay, so you can select the data, write the data from any random processor you can pick up, and you can write the data from that one. Now priority. So what will be happen in this case? Okay, there is one predefined priority list will be there. Okay, so what happened, the processor will with the highest priority will be proceed, and all the other processor will get fail. Okay, so the priority will be given to the highest processor. जो भी list में आपका highest processor list out होगा, then the priority will be given to that processor. And then last one is considered as a write the sum of all the data atoms. Okay, so basically these protocols are going to be used to resolve the concurrent writes problem. Okay, so this is the first part of your physical organization, that is architectures of your idle parallel program. So now we'll see the second part. Okay, that is in elements are there. So interconnection network carry the data between processor and the to the memory. Okay, you can store the data to the memory, you can retrieve the data from the memory. So we need the interconnections. Okay, we need to interact these processors and the memory will needs for the data exchange, or we can say for the data transfer between the processing elements and the memory. We require the interconnections network. Now how we are going to be made these connections? So by using the switches and the links, we can connect the different processors and the memory elements. Now actually if you are considering the interconnection, now it is depend how many outputs are there for a particular network. Okay, and according to that the interconnections will be considered. So here again it is depends on what kind of networks you are going to be used. Okay, so interconnection can be classified as a static or the dynamic. Okay, so static network is consist of the point to point communications link among a processing nodes and are also referred to as a direct network, where dynamic networks are built using the switches and the communications link. So dynamic network are also referred to as a indirect network. Now what happen in dynamic static network exactly and the dynamic networks? Okay, so here for communication purpose or for the interaction purpose in static network we uh, having direct links in between the processing nodes. Okay, but in case of dynamic network, if you want to make a communication between the processing node, then you can make a communication with the help of switch. So there is a switch is present in between the processing nodes, and via switch you can communicate with the different processing node in the network. Okay, the connection in case of static network, it is considered as a fixed one. That's why it is considered as a static network. In a dynamic network, the connection is not a fixed one. Okay, so if there is a direct link is present for the communication purpose, that's why this static network is called as a direct network. In case of dynamic network, okay, the link the processing nodes are connected via the switches. Okay, that's why it is considered as a indirect networks. Now in communication, for the communication purpose, and for the routing purpose, because what happen, it may be happen that suppose there are five processing nodes are there in the network, static network, and the processor one want to communicate with the processing processor 5. So what will be the happen, there may not be a direct link is there. Okay, it is connected via processor 3 or processor 4. It may be happen that, so the that particular routing should be happen. Okay, so first processor will first communicate with the processor 3, and then processor 3 will be communicate with the processor 5. So for that purpose, routing purpose, we are using the nodes, okay, in the static network, and in dynamic network for routing we are using the switch. Keep in your mind. Okay, it may be a MCQ questions, objective questions for you. Okay, in static network, if you want to perform the routing, a processing